Hey folks, how's it going? This is Mr. Murray coming to you with the third video in our Quadratics Changing Forms installment. Changing Forms of Quadratics 3. So, if you have not seen Changing Forms of Quadratics 1 and 2, I do encourage you to take a look at it. I will have right now Changing Forms of Quadratics 1, the link to that come up so that you can take a look at that. And in that video, we discussed how to go from factored or intercept form into standard form. In this video, we're going to start talking about how to go from vertex form into standard form. Okay? So remember, this is a vertex form, right? This has a vertex of hk. And what we're going to learn is that we can really just recycle the framework that we've already developed with the box and use it with the vertex form as well. So we have that one strategy that will continue to work. If you go to expand.willnot.fail, where there's plenty of practice for you, these you're going to find mostly under the medium. Okay, so in the medium problems, a is going to be equal to 1. And then in the spicy problems, a is going to be not equal to 1. So it could be like 3 or 5 or -4. You'll see all kinds of examples today. Okay, and as with the last videos, there's going to be problems for me to do, us to do, and you to do. All right, so the main ideas here are two: squaring and distribution. So we're going off the distribution that we've already done, but now we have this notion of squaring because we've got that x minus h that's being squared. All right, and so when we square, it means to multiply by itself, right? So 2 squared, well, 2 squared literally means 2 times 2, and we can simplify that as 4. X squared means x times x, right? X times itself. And similarly, x plus 2 squared means x plus 2 times x plus 2. And we have a way to do distribution here because we have the box. And now using the box, we can figure out stuff like this. And it's going to be just taking, again, like I said, what we've learned and tweaking it a little bit, right? So just recall what we learned when we did standard form, okay, or rather when we did intercept form to standard form, is that we would take our two pieces, we'd put one on the top and one on the side, we'd fill in our individual areas, and then we'd add them all up and combine like terms. Again, this process was introduced in the first video and it was discussed in the second video. And I really recommend that you go ahead and you take a look at that second video. So really go ahead and make sure you're making the most of all these resources, because in that video, I go over some more examples of how this works. So what we're going to do is we're going to combine this with our good old friend PEMDAS, right? So if we were going to do order of operations, let's say I was going to plug in a number into this function. Well, the first thing you would do is you would be doing parentheses, and then exponents, and then multiplication, and then, or division if there's division, and then addition or subtraction. So when we're simplifying and we're converting to standard form, we're going to follow the same guidelines. The first thing we're going to do is there's nothing you can really do inside of the parentheses. There's already as simplified as they can be. So where we're going to start is we're going to start by doing the exponent. So we get x and 3, x and 3. So we get x squared, 3x, 3x, and 9. So we get x squared plus 3x plus 9. Now, is there any multiplication to do? Technically, there is a 1 here, but 1 doesn't change the value of anything. So if there was a 1, right, if there was something to multiply, because remember, this is what vertex form looks like in general. So you could have squaring, but you could also be multiplying by a as well. Here we won't have to worry about that. And then the last thing we have to worry about is addition and subtraction. And 9 minus 15 is negative 6. And that is, there we go, vertex form right into standard form. All right, so this is how we're going to do. First, we're going to use the box method to expand out the square. So we're going to start with this thing that's being squared. We're going to box this out. Step 1. Step 2. If there's an a value here, if there's not, you always assume it's 1 if you don't see a number. So if there is a number in front, we are going to distribute it. Now remember, this is really important. Never, ever distribute into something that's being squared. Ever. Never do it. It's not correct, because what you're doing is you're technically distributing into two things. Let me give you an example of why this is not true. So j plus 3 squared technically equals j plus 3 times j plus 3, right? That's what it means to be squared. Now, if you were to distribute, let's say there was a 2 here. If you distribute a 2, so let's say it was 2j plus 3 squared. If you distribute a 2, this is what it actually is, right? 2 times j plus 3 times j plus 3. If you distribute the 2 first, plus 6, then what you get is 2j plus 6, 2j plus 6, right? Because that's what it means to square 2j plus 6. But you can already see just the c value, when you do this out, the c value alone is not even the same. Also, this, if you do the j, this is going to be j squared. So this will be 2j squared. This is already 4j squared. So these are not equal. So never, ever, ever distribute into something squared. You can only distribute when the exponent is a 1, okay? Because as you just saw, when you're distributing into both things, it's not the same. The only thing you can do is distribute into 1. But in any case, so again, you box out the square, you distribute the a if it's not 1, and then you add or subtract the constant, right? If it's a positive, you'd be adding. If it's a negative, you'd be subtracting, right? And this is just kind of like combining like terms. Okay, so I'm going to start by showing you how this would work. So first, box out j plus 3. J plus 3. J plus 3. So I've got j squared, 3j, 3j, 9. Maybe start to look for patterns here. Notice how this is 2 times 3. And this is 3 squared. Now, right, and remember, the squaring means by its times itself. Okay, now, is there an a value? Well, technically it's 1, because you don't see 1, right? But, you know, when there's 1, don't worry about it, because 1 times something, right, keeps it the same. So this is j squared plus 6j minus 35. Boom. All right, so please make sure you understood what I did there. Rewind if needed, and then in a moment I will move on. All right, so now here's another one for me to do. So first, box the square, multiply by an a if it's not 1, and then work with the constant. So let's go ahead, set up our box. Okay, remember what's going to go up top. So we have an n plus 10 and an n plus 10. So let's do the areas. N times n squared, 10 times n, 10n, 10 times n, 10n, 10 times 10, 100. So I have n squared plus 20n plus 100. I can keep it as is because there's nothing in front of here. It's a 1 essentially. So I just do the minus 46. And 100 minus 46 is 54. Okay. So please again make sure you understood what I did there. And then when you're ready, I'm going to go ahead and move on to the next problem. All right. So again, here, start with this. Think about what's going to go up top. So up top, what are we squaring? T plus 5. So let's do this out. T squared, 5t, 5t, 25. So you get t squared plus 10t plus 25. We can keep it because there's just a 1 in front of here. Minus 17. So you get t squared plus 10t. And when you do 25 minus 17, you get 8. Okay. Now I'm going to do one where it's a little bit more spicy. So here we have an A. So first, if this was me and I'm doing this out, remember the idea of boxing remains the same. Think about your PEMDAS. First, remember we're not thinking about the parentheses. So first we would be doing the exponents, right? X squared, 5x, and you could choose to put a plus here if you want. 5x, 25. So here you do need to drop in your 5. X squared plus 10x plus 25 minus 55. So see, now you have an A value. So by PEMDAS, we're done with the exponent, but now you multiply or divide before you add or subtract. Okay, think about, this is just based, so look, what this is about is the formula is telling you, how do I figure out y if you give me x, right? That is essentially what the formula tells you. So whenever you're working with arithmetic, it always boils down to PEMDAS. So if I was to plug in a number, I would first be adding the 5 in parentheses, but before I could multiply, I would have to square it. So when we're simplifying this, before we do this multiplying by 5, we have to square it. We have to keep with the notion of PEMDAS that is underlying all of this arithmetic and kind of algebra and stuff. It's really cool how all that is tied in. Okay, so anyway, I'm going to distribute. I'm going to get 5x squared plus 50x plus 125 minus 55. And I have 5x squared plus 50x plus 70. Okay, because we do the exponents. Rewriting like this is that's doing the exponent. Multiplication by 5, the distribution, and then finally subtraction. So we go with a PEMDAS. Now again, notice how 5 times 2 is 10, 5 times 5 is 25. So you have that pattern. Because we're going to want to think about when we see these patterns, how we go the other way too. We're going to want to be able to eventually think about these going both ways. Okay, now one for us to do. So folks, when I'm going to do this, think about the process here. What is the first thing I'm going to do? I'm going to build a what? A box. Okay, now take a look here. What's going to go on the top and what's going to go on the left? On the top is going to go P minus 4, but what about the left? going to also be p minus 4 because you're squaring something, so you're multiplying it by itself. So you do this. This is p squared. This is minus 4p. This is minus 4p. This is positive 16. So I've got p squared minus 8p plus 16 plus 28. Okay, so I combine and I've got p squared minus 8p plus 44. All right, so please again make sure you understood that. And then when you're ready, I'm going to go ahead and move on. All right, so another one for us to do. What is the first step? I'm going to make a box. And what goes on the top and the left? G minus 6, G minus 6. What's going to go inside the box? G squared minus 6G minus 6G plus 36. Now, how do I write this? First, I write the 2. That's got to come down because it's not just a 1 anymore. And then inside, write G squared minus 6G plus 36. So this is an example. This would be definitely a spicy. Okay, now I distribute. Boom, boom, boom. 2G squared minus 12G plus 72. Right, you got to get everything times 2 minus 5. And so you got right up here 2G squared minus 12G plus 67. All right, so please make sure you understood what I did there. Make sure it all makes sense. Actually, whoa. Gotta make a mistake there. Oops. So I just was noticing 6 minus 6. This should be 12. So this should be 24. So this should actually be 24. Because 6 minus 6G, right? Noticing this is double and double. Just like this one, double and then squared, rather. Double, squared. Okay, and then this is multiplied through by 2 and then subtracted 5. All right, so here's what we're going to do. I've left the process here. What I'd like you to do is try some on your own. So please take a moment, pause the video. Okay, do this one out. 1, 2, 3. And then when you're ready, unpause and you can see what I got. Cool, let's do it. So x minus 7 squared. First, we're going to make the box. So we do x squared minus 7x minus 7x, 49. X squared minus 14x plus 49 minus 29. So x squared minus 14x plus 20. Beautiful. Perfect. All right, hopefully you're able to get that right. And now on to my last one for you to do. So again, here we're just going to spice up a little bit by putting a negative 4 out there in front of the parentheses. So just here, again, I'm going to remind you about PEMDAS. All right, so please take a moment, pause the video, do this one out. All right, and then when you're ready, unpause, and you can see what I got. All right. So again, here we go. We'll start with the box. So we got r squared minus 2r minus 2r plus 4. So I'm going to have negative 4 r squared minus 4r plus 4 minus 18. So I distribute minus 4r squared plus 16r minus 16 minus 18. So I've got negative 4r squared plus 16r minus 34. All right, folks, and so that is more or less going to wrap things up. Look, I hope that you were able to successfully navigate these problems. These are definitely not easy. We do have a hangout scheduled, a weekly hangout today as of when I'm posting this video. Please make sure you're thinking through these problems and thinking about the process here, and just stay at it. And I know you can be successful. So keep it up. Don't forget to love math. And remember, you can do it. All right, thanks for watching. Have a wonderful day.